some companies were there who had who were launching these type of things in their vehicles. I'm talking about 1800s and 1900s, but we were not very much familiar with that thing. But these days we are very much familiar about all the technologies which are coming to enhance the efficiency of your vehicle. Correct. So today we'll talk about these two things, that is a supercharger and your turbocharger. So the supercharger and turbocharger are basically for increasing the efficiencies of your vehicle, and we can say that we always come to know about things like the inter power is getting wasted, or we are not getting that much amount of power, or we should like if we have 110 cc of engine in our vehicle and we want its power should be raised. So these type of things which occurred in 10 years back or something like that, but now we have this type of technology that we can conquer these type of things very easily. Okay, so let's move forward. So our very first topic is supercharger, the engine booster. One thing I want to tell you that there too, if we talk about the EVs, the superchargers are different. If we talk about our IC engines, so the superchargers. So don't be confused that this was a thing for charging the battery and all, because this is not the case over here, right? This is something different. Here the supercharger is an equipment that compresses the air being delivered to an engine. Okay, as we know that we have a naturally aspirated engines. We all know about this 2-stroke and 4-stroke engines, right? And the 2-stroke engines are outdated these days, so I'm not going to talk about this 2-stroke engine. I'll only talk about this 4-stroke engine. So we have this process that is suction, compression, power, and exhaust. Correct. So this suction, compression, power, and exhaust, when the suction takes place, then at that moment the vacuum is created during that suction stroke. That vacuum is created inside your this cylinder, and inside your cylinder, and then there's atmospheric pressure difference inside and outside, and you know that the energy go from high to low, then automatically that intake valve opens up and that your charge comes inside. Correct. But now we want that power to be increased. Okay. The motive is that our power should be increased. So at that time we are now using this supercharger. And how the supercharger is going to work? Firstly, the supercharger is the equipment that compresses the air being delivered to an engine. Okay, so we are going to use a compressed gas with our air fuel mixture, so that the capacity gets increased, because you know that air is very compressible. Correct. You can compress it as much as you want to. Please just mute your mics, so that I can just deliver my lecture very easily. So, you people are comfortable in this English, na? There's like if I can go for the bilingual. You can just put your suggestions in the chat box.
Yeah.
The chat box, so that if any problem is there, I can just speak in Hindi also. So the thing is that now we have to we have a restricted space. Like we have a certain bore dia and we have a proper volume. We cannot increase that volume, correct? But now the thing is that how we are going to increase that part? If we have only that sufficient amount of space, we have a restricted amount of space we have, and we have to improve that part, that our efficiency, the volumetric efficiency, the thermal efficiency, how we are going to do that thing. So for accomplishing that type of thing, for having the improved version, we can say that of the engine, we are introducing the supercharger. Okay, in which we are going to have that compressed compressed air which will be inserted in the intake manifold, and due to that the power the density, the air will be dense, the fuel will be burned properly. Okay, So now I'm going to read this slide. I guess the point of mine is very much clear to you. And after that also I'll explain everything. Okay. Allowing the combustion chamber to overfill without enlarging the space. As I told you, the higher concentration of oxygen provided by a supercharger is matched with large amount of fuel from the fuel injectors, thus boosting the power of the engine. It can be used in both type of vehicles. It can be used in CI and as well as in SI. So there is no problem using in CI because we are going to use that compressed gas only, because in that suction, during the suction stroke, we have to use that compressed gas. Correct. But if we talk about our SI engine, there we have charge. Charge means air plus fuel, right? Okay. So now the thing is that for both the engines, we have to raise the efficiencies. We have to generate more power. So that is why we are delivering this compressed air, so that the amount of air will now will be more, and proper burning will take place. Okay. Okay. So now the question arises: why supercharge? So initially only I told that we have to increase the power of engine. And next thing, increase the torque produced. As the power will produce and torque will automatically be produced. An efficiently working supercharger can achieve the same speed in 1/3 time. If we have a proper system where the power is get doubled, and in that same capacity engine, then definitely we can raise our speed in a very short duration. Okay. Next is necessary in aeroplanes as they have less oxygen at high altitudes. In the initial days, we have in 1800s, but after that it was not very much popular. But the starting thing was with the aeroplanes only, because at high altitudes we have less oxygen, and at that moment, for proper burning purpose, we require oxygen. Okay? Because without oxygen you cannot burn anything. You cannot gain that amount of power. And if you know that in high altitudes we have less amount of oxygen is there, you can say that less amount of air is there. So in that case, superchargers plays a very major role. Okay. So as they introduce superchargers, they have a proper amount of oxygen, which was in terms of compressed air, and so the proper amount of power was being generated. Okay, so now the next point is that ensure complete combustion of the fuel. As I told you that when you have a proper amount of oxygen there, and the proper flame speed will be there, then proper burning will take place. If we generally hear these type of problems that the proper burning is not taking place, on fuels are coming into the atmosphere, due to which the emission, because of those emissions only the pollution is getting raised these days. Correct. And pollution is a very important matter currently, as because of that only we are seeing the smog in Delhi, right, and in many big cities. So it also ensures that the fuel gets completely burned. Correct. And the next thing is that if we have a proper burning of fuel, then automatically the pollution will get reduced. As after having the BA6, we have certain types of we can say that accessories, or we can say that the equipments are there in our vehicles, like catalytic converter, like dog, like BPF. Lots of things are there who literally exist to uh, just we can say that to reduce our emissions, whatever is coming out our vehicles. And we have also we are introducing that charcoal canister and few more things, so that this emission, that evaporative emissions also can be taken care of. So the supercharger is not only helping to increase that efficiency, to increase that power and power output, but also it is reducing that pollution which is coming and hampering our environment. Okay. So how it works? We all know about this phenomena, as we all are familiar with this rich mixture, lean mixture, and chemically correct mixture, right? So lean mixture is when you have the amount of oxygen is more than that of your amount of fuel. Okay, and chemically sorry, and your rich mixture is when the amount of fuel will be more than that of the amount of air. In comparison, we haven't talking about in comparison, because it will always be the ratio is always is to 1. So the fuel is always 1. The variation is in the variation will always lie in the amount of oxygen only, or we can say the amount of air only. Okay, and next thing is chemically correct mixture, which is 14.7:1, or we can say 15:1. Okay, in which we have a proper balanced amount, and which the way our vehicle produces a proper like you can say that we have that when we operate a vehicle on an economy mode, then at that moment we generally go for this chemically correct mixture. And most of the time our vehicle is, if we are driving in a very proper manner, then chemically correct mixture comes into play. Okay, so right now we have to if we talk about this perspective, then right now we have to see that we have the large amount of power should be introduced, correct? So we have more fuel plus more air, fuel plus more air. So obviously the explosion will be bigger, correct? Because we have that restricted space, and in that space we are inserting that large amount of air is there inside that because it is compressed, right? So the amount is large, the amount of air is large. So so the power will be generated, definitely it will be large. Okay, so we can say that the greater horsepower will come out, will be on our wheels. Okay, so but we cannot simply pump more fuel into the engine, correct? So we need that kind of mixture also that support this thing. So here it is our chemically correct mixture, which I told you that is 15:1, and it is essential for engine to operate perfectly. Clear? Now, okay. Now the supercharger provides more air by compressing air above the atmospheric pressure, hence providing more fuel into charge and would take more powerful explosion. As I told you about this. Okay. And next is does the increased power torque and speed achieved. So I guess this point is very much clear to you all, that how this power generates, and why this power is getting multiplied many times because of the supercharger. Okay. I have some chats. Fine. If you have any questions, you can write down in chat, and we will just discuss after the end of the session. Okay. So let's move on to the next slides. So we have two kinds of superchargers in the market. First is your positive displacement, next is your dynamic compressors. So one more thing I want to tell you. So we have division in of supercharging in two types. Firstly, which is driven by the engine, and second, which is driven by the exhaust. Which is driven by the engine, here we are calling it as supercharger, and the one who is going to driven by this exhaust gases, it is going to be said as the turbochargers. Clear? So don't get confused. Okay, so we have this positive displacement supercharger. In this, nearly we have which delivers a nearly fixed volume of air per revolution at all speeds, and fairly constant level of boost regardless of the engine speed. It will have the hike will not be there in that the amount of fuel as this root type blower will be. I'll tell you later on what is it. This is a positive displacement one, and second one is the dynamic compressor. It is as you just rely on spreading the air to higher speeds and then exchanging the velocity for pressure by diffusing or slowing it down and delivering increasing boost with the increasing speed. So as soon as you just raise your speeds, the amount of its capacity get already increased, and we have three types of, basically we have superchargers, and we are going to deal with it now. We have root chargers, which I told you about, and twin superchargers, centrifugal superchargers. There is The purpose is exactly the same. Even the purpose of that turbocharger is also the same. That the working, we can say that the working is like that. We have different designs. Okay, so I'll show you this. So we have this this section, you see, and this they mesh into one another in a way that the air, whatever is coming, that will get compressed. Okay, so they just keep on rotating. The obviously the one, if one is in the anti-clockwise, the other will be on the anti-clockwise direction, and they just mesh in that condition that the your air get compressed, and after that it will come into the intake manifold, and through that suction stroke it will come inside. Okay, so I guess you people can imagine that. If I'll just show you this. This is the thing that how it just keeps on rotating. That low pressure air comes inside, and after that, due to this meshing, the high pressure air goes outside. Okay, so after that, it will come into the intake manifold, and it will come into the chamber. Clear. So now the root supercharger usually large and sit on the top of the engine. Root superchargers are at least sufficient, supercharger for two reasons. They add more weight to the vehicle. They provide air to discrete burst instead of providing a smooth and continuous manner. So if I just I want to focus on one thing, that superchargers take powers from the camshafts. Okay, so whatever they are generating, they are all they also have to compensate because they are using that power only. Correct. So so the thing is that here also it has a very bulky arrangement. If you see the old the vehicles which are used in the olden eras, they had a proper big large setup, and with the superchargers and with a lots of noise also. So and they were so heavy. If we talk about the power to weight ratio also, then it was so heavy that how you're going to just um, uh, if we have that power, that output we get, then it will definitely half of the amount will get compensated due to the weight, because because the weight is very like, it's very bulky. Okay, so so that is why we can say that it is least efficient. See, this is the way that, see, the root supercharger is here, and we have a proper intake port, and whenever the suction stroke will take place, this will come inside. Okay, and if I talk about that this SI1, then here will be the calculator. So I guess there will be no problem in this diagram. You all must be knowing about all the components. If not, then I just make it clear that these are the walls, these are the cam lobes, and these are the overhead cams, and SOHCE single overhead camshaft, and because of this only this the opening and closing of walls takes place. This is the piston, the side of the piston is known as skirts. This is the crown, and the head of the piston is known as crown, and these are the oil rings. The two are the above two are the compression, and the lower one is the oil ring. And this is the crankshaft, and this because through this crankshaft only we have a proper chain belt arrangement over there, which is going to drive this and drive the supercharger. Correct? Okay. Now we'll come to this twin supercharger. What is this twin supercharger? A twin screw supercharger. We have a thread type of arrangement is there, and they are going to just like mesh like this. Okay, so if they get inserted like this, so the gap between the two is very less. So when the gap there between the two, we can say, if I say like the after meshing, if the gap between the two is very less, then the proper squeezing of that air will take place. And due to that compression, the air will get highly compressed. Okay, so here I'll just read out this this presentation. That a twin screw supercharger operates by pulling air through a pair of meshing lobes Machine lobes that resembles a set of worm gears. A twin supercharger compresses the air inside the rotor housing, as we see in the diagram here below. See this diagram. Here we have this meshing condition. Okay, and the air comes inside from here, and this just as they are meshed in a very proper manner, so the air will circulate through this direction. Okay, okay. Now as the air pocket shrinks, the air is squeezed into a smaller space. I told you that. And the next is the twin screw superchargers are more efficient compared to the root superchargers. Obviously, they are, because during the meshing condition, the space between them is very less, and they had a proper meshing condition. And due to that, the air gets compressed in a very proper manner. Next is the cost. They cost more because the screw type rotor more precision in the manufacturing cost. Obviously, if they are more efficient, then definitely the cost will be higher. Okay, now I will talk about this. Now I will just talk about this centrifugal. We all know about this the term centrifugal. Centrifugal means when something rotates, it has a tendency to move outwards. Correct. You all must have heard about this in your from class 9th onwards. You just hear about the centrifugal. Okay, so you also heard about the centrifugal turbine. Correct. So the mechanism of this centrifugal supercharger is equally, like, it is basically same as that of your the term centrifugal refers to. Here, this the air comes inside from one end, and because of the turbine, it gets highly compressed and just come out. Okay, you have heard about this centrifugal pumps or centrifugal turbine, that we have a rotor in between, that motor in between. We have blades, proper blades in between in the center housing. You must have heard about it. So okay, so it will get rotated because of this crankshaft, and due to that rotation, the air from that atmosphere is sucked, and after that it will keeps on rotating, and that air comes in between and gets circulated, and due to which the compression of the air took place. Okay, so a centrifugal supercharger works by the powering an impeller, the mid one, that thing with the blade, a device similar to a rotor at a very high speed to quickly draw air into a smaller compressor housing. Next is impeller speed can reach up to 50,000 to 60,000 RPMs. It can reach up to, it can go up to 150,000 also. Centrifugal superchargers are the most efficient and the most common induction system. They are small, lightweight, attachable in front of the engine. So this, as we compare it from the rotor one, then that root one was very bulky. It was using most of that engine's power it was generating power, but very less efficient, right? Because it was generating the power, it was generating the thing, but most of its power is going in to compensate its own weight only, right? So here it is not the case, because this housing is like very less in weight. It is a very small arrangement in which we get a proper compressed air. Okay. Now we'll come to this turbocharging. What is this turbocharging? This turbocharging is that the only difference, the very basic difference is that there we were using that crankshaft power, that engine's power only through the crankshaft to rotate or to operate the supercharger. But now we are not going to use that power. We are going to use the power of the exhaust gases, that the gases which are actually waste in nature. Okay, we are going to use that gas to just rotate the turbine, and because of that, as we all know, that there are very high pressure, high temperature gases which comes out from the exhaust pipe. Correct. From the exhaust manifold. So there we make an arrangement that we have a proper impellers will be there, and due to that the turbine will move And because of that motion, the rotor on the one section, or we can say the blades on the one section, will also move because we have a same shaft. And that after the rotation of that shaft and that blade, the fresh air comes inside and get compressed and and will be entered through the intake manifold. So here what we see, here we are seeing that we are not using that engine spare, we are using that waste gas to provide, to enhance that capacity of your engine. Correct. To insert the compressed gas inside your intake manifold, we are using we are taking the help of your exhaust gases to move the turbine. Because of that, the shaft will move, and because of the movement of the shaft, the rotor will move, and because of the motion of that rotor, your fresh air comes inside, and after it comes inside, it will get rotated. Because of that, it will get compressed, and after that after the gas is getting compressed, we'll just send it to the intercoolers. Now the question arises, ma'am, why we are going to send it to the intercoolers? Because when these exhaust gases will help to rotate that turbine, the temperature of these gases are very high, right? And there is a exchanging of heat also took place here, not directly but indirectly. They are not in direct contact, as exhaust gases and the fresh air is not in directly contact with each other. So the motion will transfer, but the temperature will get raised of these fresh air also. And due to we cannot insert that high temperature air inside your intake manifold. As you all know that if we were going to insert this high temperature air, then lots of problems will take place, like the wear and tear and this knocking, and because the automation will takes place, right? Because it will be already it is in a very high temperature, and also that type of pollutants like NOx and all will also occur, generate inside, because we all know that the generation of NOx is directly proportional to that of your raise in temperature. Okay, so we have to keep all these points in our mind, and that is why we use intercoolers in between, so that the exchanging of heat will take place. And rest of and after just getting a little bit cold, the air is transferred into your intake manifold. Okay, this compressed air. Now I'm going to read this presentation. I hope you all have understood. So then I will answer your question later on. Okay. So a turbocharger consists of a compressor wheel and exhaust gas turbine wheel coupled together by a solid shaft that is used to boost the intake air pressure of the internal combustion engine. The exhaust gas turbine extracts energy from the exhaust gas and uses it to drive the compressor and overcome friction. In most automotive type application, both the compressor and turbine wheels are of the radial flow type. Some applications, such as medium and low speed engines, can use an axial flow turbine wheel instead of a radial flow turbine. The flow of the gas through a typical turbocharger with a radial flow compressor and turbine wheels. Okay, this is the diagram which you see on the right hand side. Here we just have a look. We have a compressor wheel and we have a turbine wheel. The red arrows are showing the exhaust gases, and the blue arrows are showing the fresh gases. So as your exhaust gases comes to this channel, and they just because of that high pressure, they used to revolve this rotate this turbine in one direction, and as the shaft is interconnected with that, because of that only the compressor wheel will also start rotating. So the rotation is around 1,50,000 RPM, approximately it is up to that. And because of that high rotation, the friction takes place, and the temperature of the shaft also get very high, and also the temperature and these gases are very very high temperature, so the whole thing is getting very hot. Due to that, this compressed air, and after that compression only the temperature also raised, and because of the other phenomena also the temperature raised. So the temperature so the temperature is very high due to all the combinations of all the things. Okay, after that we put an intercooler over there. So I'll show you how. Okay, I'll just show you it now. Okay, how does I have a video. I'll just share it with you. I'll show it to you that how it works. Okay, so I hope my point is very clear. Okay, so what are the advantages of this having the supercharger with ourselves? One thing is that it improves torque at low RPM in the case of diesel engine, and over a whole speed range in case of the petrol engine. Okay. So it is very obvious, as we have talked in supercharger also, that when we introduce this compressed gas, the amount of air will get increased automatically. The density of this air will get increased. Okay, because we can large amount of air can be compressed highly and can be inserted into the very low volume space. That is a matter over here also. So so that is why the generation of power will get improved, so the torque will get improved. Okay. Next is better mixing of air and petrol in case of the petrol engine, resulting into effective air pollution control. Obviously, if there is a proper mixing will be there, then and the proper turbulence will be there, then definitely a proper flame propagation will take place and proper burning will take place. And because of that proper burning, there will be no unburned charges left behind, and because of that, so this method will be highly effective in controlling the pollution. Okay. Next point is that the engine runs smoother and quieter. Yes, the engine will be smoother and quieter. We don't have that type of belt arrangement, something like that. We have a proper arrangement in which we are going to use exhaust gas only. Okay, so the process is smoother and quieter if we compare it with that supercharger. Okay. Next is it reduces the diesel knock. As I told you, if there is no auto ignition is taking place, then definitely there is no knocking in your fuel in your engine. Okay, if this your diesel knocks only took place when this auto ignition took place and the failed propagation is not proper, only knocking thing takes place, whether it is in petrol or whether it is in diesel. Okay, is in starting from cold. If we have a we all know that if we have this cold starting condition is very common with us, because in olden days we see that our vehicles is not getting started because of this because of the it is not started from long time, or it is standing at a place for a long time. So here, because at that time, what we take a choke and we just the throttle get that the butterfly valve, the carburetor get open, so the large amount of air can get inside and have a rich air fuel mixture. It will get close, and which we have a rich air fuel mixture so that the proper burning could take place, right? Correct. But here we have we are providing with rich air, with rich fuel, we are also providing a proper amount of air so that a proper burning will take place. So this kind of condition will not occur, that it will not start. Next is less smoke during the low speed acceleration. We have a less smoke will be generated as the proper burning will take place. This time kind of black fuel or black emissions will not take place. Improper horsepower in case of both petrol and diesel. Improved horsepower, sorry, in case of both. So we have already talked about this point, that when the power is properly developed, then definitely we have a proper torque. Okay, so we also have some disadvantages also. So the disadvantages are that we have intense better cooling system because heat will be very high. So we have to provide these better cooling systems. So additional, we have to do something. We have a proper cooling arrangement like heaters or something like that. We have to provide the passages over there so that the proper heat can took away. Next is design becomes expensive and complicated. Yes, of course, because we are providing this. We have two sections of one is the compressor wheel and next is this turbine, and we should have a proper channel to. We have to channelize everything. Okay, so yes, it is expensive. Next is wear and tear is at a faster rate. This it will have to run at very high RPM, so friction is very high. So and the this temperature of your gases is also very high. So these are the things due to which uh, we have to think about this its wear and tear rate. Okay. So we can also say that the mechanical load becomes high and it is complex and the cost effectiveness is not there. So these are some challenges. Okay, and in short, if I say that we can say that if I talk about this mean effective pressure in terms of mechanical, so when mean effective pressure is increases, so the power output is increases, and after that after we increase the power output, our thermal efficiency increases. Okay, so we can say that the more torque or more power output is obtained for the same displacement volume. If we have this 110cc engine, then also we can produce more power. It is not like that in the olden days. It is like the power of the engine can be restricted to this much only. Now this is not the case. Okay. So the specific, if we talk about the specific power, then the power output by per unit area will be high. Okay. I guess you people are getting my point. If I am, I guess I'm very much clear. Okay. So next is your need of the turbochargers. So first thing is that the turbocharger component are made from the special material process and a precision built to work under the extreme operating conditions. That is very true, as we already have discussed that about this, the high pressure, high temperature gases. So the material which we are going to use should be like that. The material which we use to build that turbocharger should be like that. That it shouldn't get corroded or shouldn't get burnt out, something or something like that. Wear and tear should not take place very simultaneously, very like, rapidly. Next thing is that we have a adequate in clean engine oil and clean air for its proper performance and extended life. So the filters are there to just provide the proper clean air so that this accumulation of dust and dirt should not be there, and this scaling should not be formed. Okay, so why turbocharger need them? Because we need all these two things because this assembly rotates from 1 lakh to 250,000 rotations per minute, and the clearance between the rotor and the journal are extremely small, and the parts of the machinery are very close tolerance 0.005 mm. So if we talk about this, this is very complex as the amount of clearance between the two is very less. So we know that if something gets in between, or if the clogging takes place, or something like cavitation takes place, then it will become very difficult to just clean that. The only option will be replacing it. Okay. Next is your turbochargers uses fully floating journals that rotate at half speed of the rotor assembly. Okay, so we have a proper arrangement of using this uh, this thing. These generals are just rotating very fast. So And if we are not going to have this proper materials, then definitely these things become very loosen, or we have to replace that if we get corroded or break or wear at some moment, at any moment. Okay, so filtered oil at the required pressure is essential to lubricate and cool the channels. Lubrication is taken care, and it is like it is used continuously, because we have to do that as the friction is very high, and you have already seen that it is going to up to 250,000 rpm. So the speed is very high. So without going for this, we cannot just operate this turbocharger. Okay. Next is the turbocharger components are balanced to a very fine balancing limits. Of course, they should be, because if if we want to have that nicer and quieter and smoother operation, then definitely we should have a proper balancing limits, and also that the weight should not be very high, and the vibration shouldn't take space. And next is the air or gas entering the compressor turbine housing travels at a very high speed. So that is why there is very need of like a proper designing, so that whatever enters shouldn't just hit hard on one end. The edge is not there. It has a very close surface. Okay. So this is a difference between a turbocharger and a supercharger. It is a chart. So I'll just read on one by one, and I'll just explain everything. First is we have discussed about everything here. So the first point is the turbocharger is not connected directly to the engine. So I just told you about it, that it is not directly connected to the engine. It is operated through your this exhaust gases. Next is the supercharger is a direct connection with the engine belt. Yes, the crankshaft is used, and via belt we just transfer that motion. Next is it has a smog altering equipment that lowers the carbon emission. So after burning, we have a proper setup with a small altering, due to which the smog is not generated, and other harmful emission is not generated, and because of that, this carbonation doesn't take place. So it will be, see, nothing is ideal in nature, so it will take place definitely, but the amount will be less. Next is the supercharger does not have a waste gate, so the smoke from a supercharger. Okay, I just want to tell you about this waste gate. We have a waste gate in supercharger, and if the capacity becomes very high to just if it is unable to hold that thing, then through the waste gate, the thing is that emissions are transferred into your catalytic converter directly. So that is why this becomes treated. Okay, but we do not have the supercharger. We do not have this facility in the supercharger. So it will, sorry. Okay, so it will go through the supercharger completely. It uses exhaust gas for its energy. I told you that it is, and here we use this crankshaft for the engines for its energy. So here the spinning rate is 15,000 rpm. There the spinning rate is 50,000 rpm. So the spinning rate is very high in case of supercharger. Next is that this is a device consisting of both the turbines and the compressor mounted on the same shaft. We have turbine on one end, and we have a shaft, and from the shaft only we have that spinning wheel, or we can say the compressor wheel, which is connected on the same shaft. Here we have basically a compressor is there in that supercharger, which is used to compress this. Okay, we have only a single arrangement which is used to compress these gases. Clear. Next is it does not need any extra power. Yes, for sure, there is no need of any extra power, because those exhaust gases are enough to compress these fresh gases. Here the supercharger extra power is to be supplied. So if there is a need, then as soon as you just increase the power of the engine, the power becomes extra for the superchargers again. Okay, so it draws power for the exhaust gas from the exhaust gases. It draws power from the engine. That is clear. Higher speed achieved, greater acceleration is achieved. Yes. in this turbocharger, we achieve very high power. Okay, because the RPM is very high. Here, the acceleration is achieved. In this, we have three types of, as we have discussed, we have three types of superchargers, and that dynamic one compressors, in which the dynamic compressors are there, the acceleration is multiplied. So it takes time to spin up the speed, hence there is lag. There is a turbo lag because as soon as we start the vehicle, the starting of turbos doesn't take place simultaneously, and due to which there is a lag initially. But as soon as the engine gets started in a proper mode, then there is no lag. Okay, the lag is something as just as you started and just as the vehicle started, there is a when the exhaust gas comes out, then only the turbine is going to move. Okay, and after that, the moment of turbine only, the compressor will get started. That compressor will get started. Okay, so this difference is known as lag. Okay, but if we talk about the supercharger, there is no lag. So whatever we can have that generation of that power immediately, that multiplication of power immediately. Okay. So this is turbocharger is a little bit difficult to complex in design. So so the maintenance is also very difficult. And if you talk about the supercharger, then the maintenance is very easy. Turbocharger is costly, and if we talk about the supercharger, it is less costly. Okay. So I just want to have a look on this video. This is your you'll find out this type of supercharger. Okay. Here you'll just see that how this small thing is going to just, this is a root type. See, this is a root type. You can see the design. See how the air is entering into the part. See, as soon as you just press the pedal, it can increase. The power will increase because acceleration is taking place. Okay, so your increase speed, increase your speed, accelerate, and the speed of this also get increased because of the crankshaft. See. Now we'll see this. This is your turbocharger. See here the intercoolers in between. This blue line is this this blue line is showing is your fresh air, and this red one is your exhaust gases, and the box in between is your intercooler, through which the temperature will be reduced. Okay, so that we can have a proper pressure which we just give it to provide it to the suction to your chamber, to your cylinder, wire intake manifold through the duct valve. Okay. So so thank you. This is from my end. Anybody? We have few questions, I guess. I just. It is costly because it has a complex design data. That is why it is costly. And because we are using a lightweight structure to provide to maintain that type of power, and we are using the exhaust gases, so the material which we are going to use to manufacture this is also get changed. Okay, that is why it is costly. So low speed and supercharged. Superchargers is for low speed, obviously. But yes, it will get accelerated as soon as you just put acceleration. Because in turbocharger we get speed, but in if we talk about this this thing, superchargers, we can accelerate it easily because it is directly connected to the crankshaft, right? The engine setup would generally we use this turbochargers. Yes, we have superchargers also in the vehicles. We have if we you must have seen in cars, it's written turbo, it's written. So can we use electric motor to run compressor? Yes, definitely you can have this electric motor also can be used to run this compressor, but again you have to generate that power, and again the batteries should be there, and it's really lots of high amount of energy. Okay, so again the thing is the same, the weight will get increased. So again the power whatever you're generating will be whatever the power you're generating is going to be get compensated by the supercharger, the setup. Okay, why turbocharger is a better choice than supercharger? Turbocharger is better because you are using waste gases. Because if you use it or not, it is wasted, right? So here, instead of using that crankshaft speed, instead of just getting tired with the crankshaft, you're using that waste thing. So you are utilizing that energy, right? So that is why. What's the main reason for turbocharging high efficiency? It is of high efficiency because the temperature and pressure of those your exhaust gases is very high, correct? Because they are the high pressure gases which comes out from your exhaust manifold. So that is high thermal energy they are carrying. So we are currently we just use that energy. So obviously the efficiency is higher than that of your the efficiency. We can say that if the turbocharger, the supercharger are also very good. But the thing is that they are using that energy they are taking that energy from crankshaft. Okay, so instead, I'm not saying that we are not using this supercharger these days. Okay, supercharger is being used. It is currently in use. Okay, so it is not like that it is not being used. It is using. We are using that also. We are using that also. So these are the two type of technologies we are using in current scenario. Okay. Initially, this is the lag the turbo lag is there, as I said. Initially, without just having this exhaust gases, it cannot be get started. Clear. So this lag comes, and this is the challenge with the turbochargers, and this is not the case with the superchargers. So everything comes with the challenges, no? Everything has a limitations. So this is the limitation with the turbocharger. Actuator is something which is used to detect. Okay, it is nothing like actuator is directly connected to the ECU. Okay, it is only to just performing the operations. Okay. Okay, I guess I am very much clear. Okay. Please, ma'am, summarize this chapter in some minutes. Okay. So we have talked about these two things. One is supercharger and one is turbocharger. Correct. So supercharger is a thing which is driven by the crankshaft. Okay. We have a proper belt and we have arrangement that will convert this that will provide this rotary motion, and due to that we have a proper this intake of air, and we have a setup which is known as supercharger. It has rotors inside them, or we can say that it has wheels inside them which get rotates, and due to that the compression takes place. We have three types. One is root, one is twin screw, and third one is centrifugal. Okay, and next is turbocharger. Turbocharger is an equipment which is used to multiply the power. We can say that which is used to increase the efficiency of your engine like a supercharger, but instead of using this crankshaft power, we are going to use this the power of these waste gases. In this, we have a proper setup in which we have two wheels. One is turbine, and second one is a rotor. We can say the compressor wheel. And because as a turbine, this turbine rotates because of this passing of this exhaust gases, and the shaft is interconnected with this turbine to the compressor wheel. This compressor wheel also start rotating, and because of that rotation, that fresh air comes inside, and as the fresh air comes inside, we have because of this high RPM, the temperature and pressure gets highly raised. So this compressed air is now transferred to the intercooler, and after passing through the intercooler, the temperature pressure gets little bit reduced, and after that we just pass it to the intake manifold, through the intake manifold, which is passed to the cylinder. Okay. Okay. Yeah, currently turbocharger is being used in the vehicles because it provides a very great power. Okay. It is not about if something is good or something is bad. We have two technologies over here, and I'm just discussing about that. Okay. And we have challenges with both. The superchargers also and turbochargers also. But if we talk about these high efficiency vehicles, then we generally use turbochargers instead of using the superchargers. Okay, so that's it from my end. Thank you for joining the session.